ABB UPS Sales Training. Level 0. Power Quality. Welcome to the ABB UPS Sales Training Level 0. Purpose of this training is to provide a clear picture about power quality. Introduction. The continuous advancement of technology results in developing more sensitive loads in modern electrical networks, which requires reliable and higher quality power supply. However, in today's smart grid, the large number of applications utilizing power electronic devices and the integration of DARE systems make power quality problems more prominent and threatening. What is power quality? Power quality refers to any power problem that appears in the voltage, current or frequency of the electrical network and the ability of electrical equipment to consume the energy being supplied to it. Technically, the power supply can only control the quality of the voltage, as it has no control over the currents drawn by the load. Hence, the standards for power quality are devoted to keep the supply voltage within certain limits. Power quality, if not managed correctly, can result in equipment misoperation, accelerated aging, tripping of plant, loss of production process, and can have negative consequences on the components and energy efficiency of the network. Power quality problems. A number of power quality issues impact on the operation and efficiency of electrical equipment. Sags and swells. Harmonic distortion and interharmonics. Microcuts and outages. Spikes and transients. Under and over voltage. Voltage imbalance, unbalance. Voltage fluctuations, flickering. Under and over frequency. Poor power factor. To protect critical loads. To function correctly, critical loads depend on a stable utility mains supply. To provide continuous operation to loads who are fundamental for business continuity. Below a list of utility power disturbances. Mains failure. Power sag. Power swell. Undervoltage. Overvoltage. Switching transient. Microcuts. Frequency variation. Voltage spikes. Harmonic distortion. Mains failure. Causes. This is interchangeably defined to mean total power outage or power failure. There are many causes of power failures in an electricity network. Examples of these causes include hurricanes, faults at power stations, damage to transmission lines, substations or other parts of the distribution system, a short circuit, cascading failure, fuse or circuit breaker operation. Voltage sags. Voltage sags are the most frequently occurring power quality issue, resulting in a large financial impact on facilities worldwide. Whether or not a voltage sag causes a problem will depend on the depth and duration of the sag and on the ride-through capability of the equipment. Outages are often blamed for lost time in a factory, even though a complete outage is in fact very rare in modern power systems. Voltage swells. Swells are less common than voltage sags, but also usually associated with system fault conditions. A swell can occur due to a single line to ground fault on the system, which can also result in a temporary voltage rise on the unfaulted phases. This is especially true in ungrounded or floating ground delta systems, where the sudden change in ground reference result in a voltage rise on the ungrounded phases. Definition. An undervoltage is a decrease in the RMS AC voltage to less than 90% at the power frequency for a duration longer than 1 minute. Voltage can range between 0.8 to 0.9 per unit. Causes. Load switching on, capacitor bank switching off. Overload. During peak demand periods when utility is experiencing problems. Effects. Increases the operating current causing overheating, which will shorten the life of the three-phase motor, HVAC, pumps, etc. Furthermore, large loads may fail to start if the starting torque is not sufficient due to low voltages. These stresses on the motor will eventually lead to mechanical failure. Solution: network analyzers. Three-phase monitor relays with voltage protection. Overload relays. Voltage conditioners. UPS. Definition: an overvoltage is an increase in the RMS AC voltage greater than 110% at the power frequency for a duration longer than 1 minute. Voltage can range between 1.1 to 1.2 per unit. Causes: large load switching off, capacitor bank energization, incorrect tap settings on transformers, resonance. Effects: can result in spark over and flash over between phase and ground at the weakest point in the network, breakdown of gaseous/solid/liquid insulation, failure of transformers and rotating machines. Solution: three-phase monitor relays with voltage protection. Insulation monitoring relays. UPS. Definition: periodic voltage disturbance caused by the normal operation of power electronic devices when current is commutated from one phase to another. During commutation, two phases of a three-phase voltage nearly short circuit, causing notches in the phase-to-phase voltage. Causes: variable speed drives, arc welders, light dimmers. Effects: can cause microprocessor-based control systems and computer equipment to shut down or lock up, and zero-crossing devices tripping. Solution: network analyzer. UPS. Microcuts. Definition: momentary interruption of electrical supply for duration from few milliseconds up to 1 or 2 seconds. Causes: power system faults, opening and automatic reclosure of protection devices, control malfunctions, equipment failure. Effects: tripping of protection devices, loss of information and malfunction of data processing equipment. Stoppage of sensitive equipment, such as VSDs, PCs, PLCs. Disruption and downtime. Solution: UPS. Definition: the deviation of the power system fundamental frequency from its specified nominal value, for example, 50 or 60 Hz, that go outside of accepted limits for normal steady-state operation of the power system. Causes: faults on the bulk power transmission system. Large load disconnected. Large generation source going offline. Slow governor response in isolated network. Effects: tripping of frequency-sensitive equipment. Heating and degradation of motors due to running faster or slower. Solution: static frequency converters. Energy storage system. UPS. Definition: an impulsive voltage transient, spike, is a sudden, non-power frequency, very fast variation in the steady-state condition of voltage that is unidirectional in polarity, either positive or negative. Typically ranges from several microseconds to few milliseconds and could reach several thousand volts even in LV. Causes: lightning. Poor grounding. Switching of inductive loads. Electrostatic discharge. Effects: these electrical disturbances can damage the components of electronic equipment, cause process controls and adjustable speed drives to trip, upset computer processes, and corrupt data. Solution: surge protective devices. Composition of harmonics. Any distorted waveform is composed from harmonic components and can be decomposed into a sinusoidal at fundamental frequency and a number of sinusoids at harmonic frequencies. The harmonic current frequencies are n times the fundamental frequency in a 50 Hz network. A 150 Hz, 3 by 50 Hz, waveform is the third harmonic. A 250 Hz, 5 by 50 Hz, waveform is the fifth harmonic, and so on. The decomposition of the waveform in the figure would result in the fundamental, which is superpositioned by the 5th, 7th, 11th, and 13th harmonic. Please find below a picture of ABB UPS products. Single phase. 3-phase modular. 3-phase standalone transformer less. 3-phase standalone transformer based.